All right, so for this one, guys, okay, very similar to your vectors assignment. Okay, you got 11 problems. They all have to do with Newton's second law. Okay, some of them are quite simple. Make sure you're looking at the point values for that. Okay, if a question is out of 2, there's not much to do there. Okay, but be mindful of things like significant digits and vectors. Okay, that's where people lose marks needlessly. Okay, they forget those two things. So remember to watch for those. Okay, not really much to tell you about 1 or 2. They're pretty straightforward. Okay, number 3, you're looking for the vector components of that given force. Okay, they're telling you it's 720 newtons and it's 38 degrees north of east. So you're trying to find the north and east vectors. For number 4 is 3 separate problems. Okay, so they're giving you the free body diagrams for essentially like part A, part B, and part C. Okay, you are being asked to calculate the acceleration of this mass. Okay, it's 5 kilograms. Its mass is 5 kilograms. Find the acceleration of it based on the forces and the directions they're acting. Okay, so you got to do whatever you have to do to find acceleration of those 3 situations. All right, so make sure you're looking at them in terms of vectors and things like that. Okay, number 5 is also vector, but it's a bit tricky because you're going to have to go backwards. Okay, it's telling you that the acceleration of this object is 3.96 meters per second squared, 21 degrees above the x-axis. So you have the final acceleration, which you can use to calculate something else important. Okay, and they're telling you that there are 2 forces that cause that. One of them is this force. The other is the force you have to find. Okay, so you have to find the missing force. And I will tell you, it's going to be vector based. You're going to have to use vector stuff to find that missing force for question number 5. Okay, the hint I'll give is kind of vector subtraction, so much vector addition. But okay, for number 6, there's a lot of words and not as much math as that would imply. Okay, so don't let all the wording here trick you. Okay, the ship has 4 engines. You can only fire 1 engine at a time. When the engines are on, they are at maximum. There's no throttle, they're on or off. Okay, when they are on, they can exert 68,000 newtons of force. All right, which engines do you need to fire to accomplish the maneuver that they describe here? All right, this maneuver will contain 2 steps. Right? It says initially you are moving in this direction at 2,170 meters per second. At the end of this maneuver, you want to be going clockwise 90 degrees at twice that velocity. All right, so you need to figure out which engines you need to fire and for how long. Okay, so you're going to have to do some forces and accelerations and things like that for that question. Okay, 7 and 8, we have done questions exactly like these in class, right? They are static questions, so watch out for those. You guys know how to do them. We've done ones like them before. Okay, you guys know how to do them. All right, question number 9. Okay, suitcase being pulled at a constant speed, pulling on a handle that makes an angle that's unknown with the horizontal. It tells you the frictional force, okay, and it tells you also that the person exerts 43 newtons of force on the handle. All right, so we know some of the forces there. We did one like this the other day. Okay, an object pulled along a horizontal surface at an angle. Okay, it's moving horizontally, but it's pulled at an angle. That's the most important thing you need to realize for that one. Okay, 10 and 11 are your inclined plane problems. Please look at the wording carefully as they tell you the box's weight in newtons, not the box's mass in kilograms. All right, questions? All right, have at it.